Now this presentation is on the sine and cosine rules. Lesson objectives: to be able to use the sine rule to help solve problems, and secondly, to be able to use the cosine rule to help solve problems. Now there are two versions of the sine rule, but fundamentally they are equivalent. So if you've got a little a as a side and the capital A being the angle opposite, little b being a side and then capital B being the angle opposite that, and if you've got little c and capital C being the angle opposite that, then little a over sine A equals little b over sine B equals little c over sine C, or equivalently, sine A over little a equals sine B over little b equals sine C over little c. Now you use the one with the sides on the top if you're trying to find a missing side, and use the ones with the angles on the top if you're trying to find a missing angle. The cosine rule is a squared is equal to b squared plus c squared minus 2b times c times cos of a, where the sides and angles are pretty much defined the same as the sine rule, with the capital letter being the angle and the lowercase letter being the side, on the opposite side of that angle. So in this case, we've got a triangle with one side 8 centimeters, two angles A and B of 30 degrees and 40 degrees, and we're to find the length of the missing sides and the size of the missing angles. Well, in this case, we should denote our missing side. So the side opposite capital A is little a, the side opposite capital C is little c. Now in this case, the easiest thing to work out is the missing angle, because we've got two angles of a triangle. All the angles of a triangle should add up to 180 degrees. So capital A plus capital B plus capital C is equal to 180. Now we've got capital A and capital B, so we can fill those in. 30 plus 40 plus C is equal to 180, and then we can solve to find the C. So C is equal to 180, take away the 30, take away the 40, which gives us 110 degrees for C. Now, in order to find the missing side, we can use the sine rule. So to find, we've got side B, which is 8, and the opposite angle, which is 40 degrees. So b over sine B is the one we use to find any missing sides. And we'll start off by trying to find little a, and we can use its opposite angle of 30 degrees. And a over sine A equals b over sine B. So sticking in the values, we get a over sine 30 degrees is equal to 8 divided by sine of 40 degrees. Now we want to rearrange that to make it little a equals, so we need to multiply both sides by sine 30 degrees. So we get that little a is equal to 8 times sine of 30 all over sine of 40. Sticking that into a calculator, we get that little a is equal to 6.22 centimeters to three significant figures. And basically we follow the same procedure to find C. So little c over sine C equals little b over sine B. We've got our angle capital C, which is 110 degrees that we worked out. We've got little b and sine B as we used them in the last question. So we get little c over sine 110 degrees equals 8 over sine of 40 degrees. Now, as we did in the last bit, we times both sides by sine 30 to make a equals. In this case, we're timesing both sides by sine 110 degrees to make it c equals. So we get that c is equal to 8 times sine 110 degrees all over sine 40 degrees. And we can stick this into a calculator to get 11.7 centimeters to three significant figures. Now, lots of questions of this type. This won't be the only way of finding all the missing sides and angles, but I think in this case this is probably the easiest way that we could have approached this problem. Now, in the second example, to find the lengths of the missing sides and the size of the missing angle. Now, in this case, we haven't got two angles, so it's not easy to find the third angle. However, let's denote missing sides first. So we've only got one missing side this case, and it's opposite the capital A angle, so little a is the side that's missing. And we have little b, which is opposite the angle of 64 degrees, so little b is 12 centimetres, and little c, which is opposite the c angle, is 4 centimetres. Now in this case, we will find it easier to find angles first, because we don't have either capital A or little a, so using sine rules, we won't be able to get little a without getting capital A first. Now, to find the first missing angle, we will get angle C first of all. So sine capital C over little c equals sine capital B over B. We've got both bits of the b's, so we can use that as our way of finding the unknown. So sticking our values in, well, we don't know capital C, but little c is 4 centimetres, capital B is 64 degrees, and little b is 12 centimetres. So we get sine of c over 4 equals sine of 64 all over 12. Now we need to rearrange this to be sine c equals, so we need to times both sides by 4. So sine c is equal to 4 sine 64 divided by 12. Now a common error here is to mistake this answer on the right hand side, the 4 sine 64 over 12, as being the angle, but that is not the case. We need to do sine inverse both sides to find the c. So sine inverse of both sides gives us c is equal to 17.4 degrees to 3 significant figures. Now we've got two angles after that, so we can use the a plus b plus c equals 180 degrees again. All three angles, being angles of a triangle, add up to 180 degrees. So we stick in our b equals 64, our c equals 17.4, and then we solve to find a. Now in this case we would take 64 and 17.4 from both sides, so a is equal to 180 minus 64 minus 17.4, which gives us 98.6 degrees to 3 significant figures for capital A. And so now we've got capital A, we'll be able to use little a using the sine rule as we did in the last example. So little a over the sine of a equals little b over sine of b, because b's the ones where we've got both sides most accurately. So little a over sine of 98.6 equals 12 over sine of 64. To rearrange it to little a equals, we need to times both sides by sine of 98.6. So little a equals 12 sine of 98.6 divided by sine of 64. Sticking that into a calculator, we get 13.2 centimetres to 3 significant figures. On this example, we only need to find x. Now, if you've got the case where you've got three sides, including the one you want to know, and one angle, the best rule to use is the cosine rule. So we want to use a squared equals b squared plus c squared minus 2bc cos a. Now basically, the capital A has to be the angle that's given. So the 100 degrees is the given angle, and therefore the x must be the little a. The b and the c, it doesn't matter if you assign them to 6.5 or 8.7 or vice versa. So we end up with x squared equals 6.5 squared plus 8.7 squared minus 2 times 6.5 times 8.7 cos of 100 degrees. Calculating, we get x squared equals 137.57, and the calculator goes on for several decimal places. Square rooting it immediately in your calculator gives you x equals 11.7 centimetres to 3 significant figures. Now in this example, we want to find the angle, and we've got all three sides. So again, all three sides in an angle, including the unknown, it's best to use the cosine rule. So using a squared equals b squared plus c squared minus 2bc cos of a. Now theta will have to be the capital A because it's the only angle involved, and therefore little a will be at the opposite side to that angle, the 10.6. So we'll get 10.6 squared equals 8.2 squared plus 5.9 squared minus 2 times 8.2 times 5.9 cos of theta. It doesn't matter which we assign B and C out of 8.2 and 5.9. It works the same each way. Now calculating each little bit, we get 10.6 squared is 112.36. 8.2 squared plus 5.9 squared equals 102.05, and 2 times 8.2 times 5.9 is 96.76. So we have 112.36 equals 102.05 minus 96.76 cos of theta. And before we can find theta, we need to rearrange this to cos of theta equals. So first of all, let's add 96.76 lots of cos theta to both sides. So we get 112.36 plus 96.76 cos of theta equals 102.05. Next, subtract 112.36 from both sides. So 96.76 cos of theta is equal to minus 10.31. Then divide both sides by 96.76, so we get that cos theta equals minus 10.31 all over 96.76, and then cos inverse to find theta. So theta equals cos inverse of minus 10.31 over 96.76, and this gives us 96.1 degrees to three significant figures. Now the final example just shows how we can get a sine or cosine rule question from a more practical problem. So in this case, a footbridge is to be built across a small lake from a gazebo to a dock. From a tree 100 yards from the gazebo, the bearing is 114 degrees. From the tree to the dock, the bearing is 175 degrees. The bearing from the gazebo to the dock is 213 degrees, and we should try and find the length of the bridge. So a little quick sketch of that. If we draw the tree, we do a bearing of 114 degrees from the tree to the gazebo, and we denote the distance between them as 100 yards. And then we also draw the gazebo as being having a bearing of 213 degrees to the dock. Now, the bearing from the tree to the dock is given as 175 degrees, but part of that is the 114 that we've already got from up to the gazebo, and what we want is that missing angle within the triangle that we've drawn. So 175 degrees minus the 114 we've already got is 61 degrees. So to get the bearing correct, the angle in that triangle would have to be 61 degrees to give us a bearing of 175 degrees from the tree to the dock. And then, looking to see what else we can get, well, 180 degrees minus the 114 is 66. Now, this will be the angle here. There's a parallel lines rules with angles. So those two angles will have to be the same. This 66 degrees would be the same as the angle here. This is 66 because it's angles on a straight line which add up to 180 degrees. So that gives us 66 degrees. We've got two of the angles around a point. Angles around a point add up to 360. So 360, take away the 213, take away the 66, gives us 81 degrees, which gives us a second angle in that triangle. And then for completeness, we've got two angles of a triangle. All three angles add up to 180 degrees. So 180 minus 81 minus 61 gives us 38 degrees. We have all three angles of that triangle. So in these sort of problems, it's best to find out any kind of information you can to help us find the information we actually want, which is the length of the bridge, which is the length of the side from the gazebo to the dock. So we've got three angles now. We've got one side. So we'll denote our missing side that we want with little a. That means that capital A is the 61 degrees. And we've got an angle and a side that's opposite that, 38 degrees and 100 yards. So we can make that our little b and our capital B, as we've got both sides that we need for the sine rule to be applied. So sticking in our values, got little a over its a sine of the opposite angle, 61 degrees, equals 100 over sine of 38, its opposite angle. As with the other questions, we times both sides by sine of 61 to make it little a equal. So little a equals 100 sine of 61 all over sine of 38. Putting it into a calculator to find little a, we find that we get 142 yards to three significant figures. Again, this isn't the only method that could be used to solve this question, but I feel that this is probably the easiest. And that concludes this presentation.